We're finally to the end of section 1.1, talking about literal equations, and this hopefully will be a quick and easy video for you. So, literal equations. Sometimes you see equations with multiple variables, but literal equations specifically are ones that relate to real life, ones that relate to geometry or physics or other things that you may have seen in real life. An example is d equals rt. That's distance equals rate times time. That's a physics formula. These equations can have a lot of variables, right? It's not a univariate, it's not a linear equation in one variable. They don't even necessarily have to be linear. We want to, what our end goal is with a literal equation is to solve it for a different variable than what it already solved for. So, for example, this d equals rt. It's solved and we know what d is equal to, right? d is equal to rt. But sometimes we want to reverse that and figure out what it's equal to in terms of another variable. All we're going to do is pretend like these other variables are numbers, okay? We're just going to solve it as we would any other time. So, for example, this first example we have d equals rt. We're trying to solve it for t is what it says. We're trying to solve it for t. That means we want to get t by itself. T by itself. To get t by itself, this is the same as d equals r times t, right? We talked about a couple of videos ago the multiplicative and the additive rules of equality. And so what we can do if we want to get rid of a multiplication, the inverse of multiplication is division. We want t to be by itself, so what we can do, r times t, we can divide by r, divide by r. And just like when we're doing it with numbers, just like with regular numbers, r over r is just equal to 1. And so we have d over r equals t. As soon as we have the variable that it says, solve for t, as soon as we have that variable by itself, we're done. So that's what t is equal to. It's equal to d over r. It doesn't matter in what order that's written. We could write it as t equals d over r or d over r equals t. Those are interchangeable. It does not make a difference. Here's another example. We've got 3x plus 2y equals 6. We're trying to solve it for y. That means we're trying to get y by itself. Just like in lesson 1.1, when we're trying to solve an equation, we're going to use those additive properties first. So to get y by itself, I'm going to first get the furthest thing away from y to go away. So I'll subtract 3x, subtract 3x. What that leaves me with is 2y equals negative 3x plus 6. You could have written that as 6 minus 3x. It's the same exact thing. It does not matter what order they come in. Now, I'm trying to solve it for y. Every single step I'm going to say, is y by itself? Not quite yet. I still need to divide by 2. Divide by 2. So then I get y equals negative 3x plus 6 all over 2. Now I have y by itself, and we're done. We could break that apart. If you broke that apart, it'd be fine. You can separate it into two fractions. Y equals negative 3x over 2 plus 6 over 2, which is the same as 3. That's the same as 6 over 2. Let's try another one. Area equals, see, you notice all these are geometry, right? That's the equation of a line. The last one was distance, rate times physical. This one, area equals 1/2 height times base plus base. This is the area of a trapezoid. Let's see if we can solve this. It says for capital B. Notice it has a capital and a lowercase b. Those are two different things. We're trying to solve that for capital B. So the first thing, we can, what can we do? There's a fraction. Let's get rid of that doggone fraction. Multiply both sides of this equation by 2. 2a equals h parentheses b plus b. I've always said to distribute first. You can do that. You can distribute first. I think my preference here, if you distributed the h in, it would just lead you to do one more step, okay? My preference here, though, is to divide by h, divide by h. I'm just getting rid of one thing at a time, from furthest from the capital B to closest to the capital B. Since the lowercase b was inside the parentheses, I'm calling that h further away, right? It's not grouped along with it. All right, so 2a over h equals capital B plus little b. We're trying to solve for big B. All we need to do is subtract the little b from both sides. Is this common with anything at all in that fraction? It's not. So I cannot combine it. 2a over h minus b equals capital B. That's our solution. Again, you can write it left to right or right to left. It does not make any type of difference. All right, I have one more here. This one's going to have a little trick. So if we're trying to solve it for x, here's the trick. If we're trying to solve for a variable that's in more than one place, we need to gather that variable to one side so we can factor it out. So I'm going to show you what I mean. here's an x, here's an x. I need to gather those all to one side and get them by themselves. So I'm going to subtract cx, subtract cx. I can't combine them, but ax minus cx plus by equals d now, right? The d just came down, the by just came down. The ax and cx, it's tough to think about how to combine those. I want to get them to one side and isolate them so it's only x's over there. So I'm going to go on and subtract by from both sides. Ax minus cx equals d minus by. And I'll go on and give you a heads up now that this looks a lot like a test that a question that could end up on the test. Looks a lot like a question that could end up on the quiz. All right, here's the trick. Once you get to this point where your variable is on one side and nothing else is over there with it, you can factor out that variable. So factor out the x, just like it's a GCF. So that would be x. If I took an x out of this term, I would have just an a. If I took an x out of this term, I would have just a c. Check me real quick and notice that if I distributed this x back in, I would end up with xa minus xc. That's the same thing as ax minus cx, right? Now that I've factored it out, the next step is to divide by this thing. Divide by the thing that's multiplied by x. So I can divide this whole thing by a minus c. Divide by a minus c. And what happens is this a minus c divides away with that a minus c. And we have left x equals d minus by over a minus c. We are done. All right, here's what I want you to do. We've got one more. And this is one of those that I want you to try, right? So we have 3x minus w equals ax minus z. We're trying to solve this for x. Take a minute, see if you can solve it, pause the video, and in just a few seconds I'm going to reveal what I did. I solved it just like the last one where I subtracted ax from both sides, trying to consolidate those x's, right? Then I moved the w over, again trying to consolidate the x's and get them alone. Then from this, how did I get from this to this? I factored out the x. Then since it was x times 3 minus a, I just divided both sides by 3 minus a. Dividing both sides by 3 minus a leaves me with just an x on the left. And it did say solve for x. So as soon as we have x by itself, we know we're done with the problem. Next time we're going to take all these skills, all the things that we've learned in 1.1, and we're going to try and apply them in 1.2 to some word problems.